An astounding result occurs when copper metal is held within a really hot flame. The color of the flame begins to change color to a bright green. What causes the color change of the flame? The reason for the unique color is easy to understand if you learn a few facts about an interesting concept known as excited states. Before excited states can be defined, some basic concepts from atomic structure require some explanation. Atoms, the simplest whole unit of matter, consist of a positively charged nucleus at the center of the atom that is made up of subatomic particles, positively charged protons, and electrically neutral neutrons, surrounded by negatively charged subatomic particles called electrons. The electrons do not just move around randomly, but they occupy specific regions known as energy shells. Within the energy shells, the electrons can be found within cloud-like regions called orbitals. The electrons that are found in the outermost occupied orbitals of an atom, known as valence electrons, do not always remain in the same orbital or energy level, as they are able to absorb energy from heat or light. When a valence electron absorbs energy, it enters what is known as an excited state. The excited state can commonly take the form of the electron jumping from its original energy level or orbital, also known as the ground state, to an empty orbital of a higher energy shell that is further away from the nucleus. The excited electron does not stay in the excited state permanently, however, and eventually falls back to the ground state. When the electron falls from the excited state, it loses energy in the form of light, a process called emission. The excitation of electrons followed by the emission of green light explains the green flame from the previous example of heated copper. Excited states within the atoms found in molecules are of great importance for some chemical reactions. For example, one vital reaction for plants is photosynthesis, the conversion of ultraviolet light into energy for respiration. Within the plant, special bodies known as chloroplasts contain a green substance called chlorophyll. Ultraviolet light from the sun excites electrons in chlorophyll and results in the transfer of excited state electrons that drive photosynthesis. Excited state electrons are also significant when analyzing substances to determine their composition. As noted earlier, the excited electrons of heated objects emit light as the electrons return to their ground states. The color of light can be very distinctive, as in the case of the green flame produced from the presence of copper, and is very useful in identifying the presence of certain substances. You might actually have encountered this in a school chemistry laboratory if you have ever performed a flame test, a technique that uses the color of a flame to test for the presence of certain metals that are dissolved in liquids. Let's review. Excited states result from the absorption of energy by the outermost or valence electrons of an atom that cause a jump to higher energy shells or orbitals. The excited state electron does not remain excited permanently, but emits energy in the form of light, known as emission, in order to return to its original ground state. Excited states are important parts of some reactions as well as in the analysis of substances.